I've made this video to address some issues that came up in the class regarding atomic notation, mass number, number of protons, neutrons, and electrons. The learning outcomes are from Unit 2, the atom. They're to use the periodic table to predict the number of protons, electrons, and neutrons for any element, and to use atomic notation to represent the elements. We did this in class, but there's a slight modification that we need to add to this concept. During atomic notation, we use the periodic table and isotope names to state the atomic notation, number of protons, neutrons, and electrons. For example, when given the name calcium-41, we knew that the atomic number for calcium was 20 from the periodic table. The mass number was given in the name of the isotope, so 41. And using these two values, we could come up with the atomic notation. We'd write the symbol for calcium, Ca, and then to the left, we would write 41 on top for mass number and 20 below for the atomic number. We could then use these values to predict the number of protons, which is equal to the atomic number, so 20 in this case. The number of neutrons was equal to the mass number minus the atomic number, so in this case, 21. And finally, we could state the number of electrons because the number of protons and electrons should be equal in an atom, and therefore, there are 20 electrons. One question came up was, what if we're not given the mass number in the name of the element? We can use the same logic that we've used previously, only we need to add a single step. We need to round the atomic mass in the periodic table to a whole number in order to figure out the atomic mass that we should include in the answer. Let's look at a question together. If we look at hydrogen, we can see the atomic number is 1. We can see the atomic mass is 1.01. We will then round the atomic mass in the periodic table to a whole number using the rounding rules we looked at in Unit 1. The rounding rules, in this case, since we want to go to a whole number, are if the first decimal value is 0.5 or greater, then we will round up. If the first decimal value is smaller than 0.5, we will round down. In this case, we use the first decimal because we want to round to a whole number. In this case, 1.01, because it's a 0 after the decimal place, we will round down to 1. The atomic mass that we would give in our answer is 1. So, again, we need to round the atomic mass in the periodic table. Let's look at some examples. What if we were given a table such as this, where we were given the atomic number of some elements? Let's look at the first element with the atomic number 1. Looking up in the periodic table, we can see that the element with atomic number 1 is hydrogen. We could then look at the atomic mass number for hydrogen. We'd see that it's 1.01. Again, there's a 0 in the first decimal place, and so we would round down, and the value we would give for the mass number is 1. We could then write the atomic notation. The symbol for hydrogen is H, and we have atomic mass of 1 and an atomic number of 1. We could then go through, as we have before, and state the number of protons, neutrons, and electrons. The number of protons is equal to the atomic number, 1 proton. For number of neutrons, we take the mass number and subtract the atomic number. Therefore, in this case, hydrogen has 0 neutrons. And the number of electrons, as always, is equal to the number of protons for an atom, 1 electron. Let's look at the second example here. We need the name of the element with the atomic number 17. In this case, from the periodic table, we can see that it is chlorine. We can then look at the mass number from the periodic table for chlorine, 35.45. If we look at the first decimal place, 4, we'll round 35.45 down to 35. We can then write the atomic notation. The symbol for chlorine is Cl. We'll write the mass number on top and the atomic number below, and we have the atomic notation. Again, the same is the case for protons, neutrons, and electrons as we've done previously. The number of protons equal to the atomic number, 17. The number of neutrons is going to be 35 minus 17, 18 neutrons. And then finally, the number of electrons will be equal to the number of protons at 17. I've posted a worksheet along with this video in order for you to practice with this concept. Practice is key. We've done this all before. We just needed to add the concept of rounding if given just the atomic number or an element name without a mass number associated with it.